Once we know that a device exists on the network based on a sweep of that network, and then secondly, that it has various ports open, it would be awesome if there was some way of us discovering the actual version of the operating system or the version of the software, like a web service, that they're running. Well, my friend, there are tools to discover exactly that. When we boil it down, there's two basic categories that we have when we're doing fingerprinting of an operating system and or the services that are running, and they are active or passive. And with active fingerprinting, the attacker is directly sending stuff in to the victim and seeing how that victim responds. And that could include normal, for example, three-way handshakes to see what the responses come back like, or perhaps specially crafted packets using hacking tools. So based on even a little nuance on how a specific type of system's protocol stack responds, that information can be used to help identify or at least get closer to the type of operating system or platform that that host is running. With passive fingerprinting, we could either analyze the traffic that's going back and forth between that system and another device, and there are many ways to get that data, including doing some eavesdropping or man-in-the-middle attacks, and simply looking at the content. And with banner grabbing, our intent is to see how the device responds, and then based on that response, identify what kind of operating system is running, and as a result, line up the vulnerabilities that that system might have as a result. And what I thought would be fun for you and I is let's take a look at a few tools, some from the command line, some from a graphical user interface, that could be used to profile and identify an operating system and or the services that it's running. So in my lab topology, I've got all these machines fired up. We're going to start off here at the Kali box. We'll also be doing a little bit of work from the Windows 10 system as we demonstrate some tools that we can use for fingerprinting an operating system and or the services that it's running. So let's start off at the Kali box and let's bring up a shell and let's run telnet. You might be saying, Keith, who are we going to telnet to? Well, if we telnet to a non-standard port, we can get a reaction or response from that system. For example, let's do a telnet over to our Windows 2012 server at 192.168.1.212. But instead of just pressing enter, which would go to the well-known port of 23 for telnet, let's put a space and let's add port 80 and press enter. So currently we are connected on port 80 to this server at .212. Now I know it's a web server, there's not too much we can actually get here unless we learn to speak like an HTTP client. So what we could do here is we could go ahead and put in HTTP commands. For example, let's type in get, and I'm going to do it in uppercase, space http/1.0 and press enter a couple of times. And what it effectively just did was give that get command to the web server who responded to it. So if we scroll up, so this is what I typed in, and I pressed enter a couple times. So I got an OK message back from the web server. It also shows me right here the kind of web server it's running, and that's basically a banner grab. We've just discovered the web server type that's running on that system based on the banner information we just got from it. And if we didn't want to use telnet, there's other tools that could do a very similar thing. For example, one of those tools is called netcat. So we can type in NC for netcat. I'm going to take off the caps lock here. So we could type in NC for netcat, and then type in 192.168.1.212 space, and also identify the port of 80 and press enter. And then once again, we could use our get command of get space http/1.0, press enter a couple times, and that also feeds us back the same information, including the server type that it's running. We could also use Nmap. Now, we've already been through a few examples of Nmap, and we've had our nugget dedicated to Nmap. So to make this a little bit more fun and more graphically entertaining, let's go ahead and use ZenMap for an Nmap demonstration. So we'll type in ZenMap. You could also find ZenMap through the menu system on Kali Linux if you wanted to, but right here from the command line, it's really convenient. We'll press enter, and I'll expand this full screen. So let's just do a quick scan of the network to see what's out there, 192.168.1.0/24. And I'm going to go ahead and I'm going to add the -SN just to do a quick ARP-based scan of the entire subnet and press enter. And that should take less than about 10 seconds. Great, and it is done. Oh, fun. Okay, so this is my home office, and it's also connected to my home network here. So I've got my iPhone that's showing up. I've got an Xbox One that's showing up. It looks like my default gateway has a host name of KB. And over here I've got a question mark on the OS, and that's because the scan we just did not go far enough into asking what ports were open and or trying to identify the operating system and or the flavors of services like web services that are running on that system. For our example, though, we've got this .212, which is our Windows 2012 server. And if we wanted more information on that device, we could go ahead and just do a more intense scan of that one IP address. So here we can type in 192.168.1.212. And over here from the drop-down for the profile, we could go ahead and do an intense scan. And what I'm going to do also, I'm going to add on to this intense scan, I'm going to add on the -O with a -O, which, if it wasn't already baked into that command, is also now going to try to discover the operating system of that host. And we could actually run this across the entire network, but it would take a long, long time. I just want to demonstrate this on a single host so we can see the results of that. So with that put in, we'll go ahead and press enter, or we can click on scan over here in the upper right hand corner. Either way will launch the scan. And then right here it indicates by that bar that's moving that the scan is still running. And what we're hoping for when the scan is complete, we're hoping for additional information about this host here, including the operating system. Our scan should also identify the ports open on that device as well as the type of web server running on port 80, which will give us additional information on that system that we could then possibly use to compromise it. So the scan is still running. Down here it's indicating how it's doing and an estimate of how much is left through the magic of editing. I'm going to have this done very, very quickly. And now that it's done, check this out. If we highlight this host, which is 212, over here on the left, it's showing us here the type of web server that's running. It's IIS version 8.5, the supported methods on that web server. And if we scroll down a little bit further, it has information about what it's currently running. So it knows it's Windows 7, 2012, or 8.1. Here in the OS details, it says that again. As far as the IP ID sequence generation that we leveraged in our idle scans, it uses incremental, which is a good candidate to use this as a zombie if we're doing idle scans. Here we have some NetBIOS name information. And if we scroll down further, it's showing us from a traceroute perspective how far away that device is. Now, because I'm all local on one common subnet, I don't have to go across any routers to get to that destination. And also the icon over here has changed because it can now identify the type of operating system on that host. Also, right here in ZenMap, if we click on the tab called Ports/Hosts, it's going to give us the ports that are involved on that host that are open. If we click on Topology, it'll give us the topology of our network. We can make that a little bit bigger if we want. There's a tab for host details. If we scroll down, there's ports used and OS classes. So that's how Nmap can be used to do additional discovery of an operating system and or services that are running on top of that operating system. Another little tool I'd like to show you is called IDserve. And to demonstrate that, let's go ahead and jump on this Windows 10 machine. So here in our Windows 10 machine, we'll do a Google search. And we'll do a search for IDserve banner grabbing. And oh my gosh, all of this here is in a virtualized environment. This is not my production systems that I'm working with. I'm in my lab. But I would recommend being very careful about downloading a tool from some suspicious, I'm doing air quotes, suspicious site. So Steve Gibson has been around for a long, long time. He's done a lot of fun work over the years. And he actually wrote IDserve. So I'm going to look for GRC, his website, right here to download the tool from, because I know it's going to be clean from that site. So I'm going to grab the link for grc.com with IDserve, select it, and then here in my test environment, I'm going to go ahead and download that, and I'm going to launch it. It's not signed. Again, I'm in my lab environment. I can reset this to a snapshot if I need to. I'm going to go ahead and run it. But that's often all it takes is just a couple of clicks for a user who has admin rights to completely have their system pwned. In any event, here I'm going to go ahead and launch server query, and let's go ahead and put in 192.168.1.212. That's my local Windows 2012 server. We'll click on query the server. It goes out, came back, and tells us that the server is identified as IIS version 8.5. If we ran it against 2016, which is our Windows 2016 server in our lab environment, we'll click on Query the Server. It says it's running IIS version 10.0. And if we went out to somewhere like www.microsoft.com and pressed enter, hopefully they're also running IIS. And maybe they are, but they're actually using a service at the edge to push out their content, and that's being hosted by Akamai. Let's do one more. Let's go to www.hackthisSite.org and press enter. And they've got a load balancer, or a server identifying itself as load balancer, that's handing out the content. And when possible, that would be a great countermeasure. If we could put in front of our server some type of a generic identifier that hides the real content or hides the real server behind the scenes, that would be a good level of protection because the hacker would not know exactly what type of OS or service is being run based on banner grabbing. There's also firewall services that we can put in front of our web servers that will help filter out some of that content so it can't be discovered. In this nugget, we took a step further into identifying the operating system and the applications running on a server by using techniques such as banner grabbing. And we demonstrated 3 different tools. We demonstrated Telnet, Nmap, and ID Serve as tools we could use to gather that information. And I would encourage you in your lab environment to test all these as well. I hope this has been informative for you, and I'd like to thank you for viewing.